Good morning, guys. Let's go ahead and start on chapter 5.1, which is bisectors or triangle notes. So first, let's look at the theorems here. We have the perpendicular bisector theorem. It says if a point is on the perpendicular bisector of a segment, then it is equal from the endpoints of the segment. So if we look at the example, it says if CD is a perpendicular bisector, so right here, CD, let me go over it. There we go. Of AB, then AC is equal to BC. So this side is equal to this side. The next theorem says converse of a perpendicular bisector theorem. If a point is equal from the endpoints of a segment, then it is on the perpendicular bisector of the segment. If AE and BE are equal, so AE and BE are equal right here, then E lies on CD, the perpendicular bisector of AB. So the point A, so the vertex E is on this line. So let's go ahead and look at example 1. Example 1 wants us to find each measure. So first we need to find the measure of AB. Well, looking at our diagram off to the right, we know that CA is the perpendicular bisector of BD. So this right here, this line is bisecting BD because of this perpendicular symbol. So that means that AB is equal to AD. So AB is equal to AD. Well, AD, which is right here, is equal to 4.1. So that means AB is equal to 4.1. So AB is equal to 4.1. Okay, now let's look at WY. So since WX is equal to ZX, so WX is equal to ZX, so these two sides are equal because they're both 9, and XY is the perpendicular to both of these segments, so XY is perpendicular to both of these segments. By our theorem, we know that WY is equal to YZ. So WY is equal to YZ. Okay. And since YZ is 3, then WY is also 3. So these two are equal. So WY is equal to 3. Now we have to do RT. Well, SR is the perpendicular bisector. So right here. So that means Q and S and T are equal, and Q and R and T and R are equal. So these two are equal. So RT is equal to RQ. Well, RT is 4x minus 7, and RQ is 2x plus 3. So I have to solve for x and then plug that back into RT to find what RT is. So then I do minus 2x to both sides, and I get 2x minus 7 is equal to 3. Add 7 to both sides, and I get 2x is equal to 10. Divide by 2, x is equal to 5. Well, now I need to plug in this 5 into RT. So 4 times 5 minus 7 is 20 minus 7, which is 13. So 13 is my answer. Okay, let's look at the next part. So now we have theorem about the circumcenter. So the perpendicular bisectors of a triangle intersect at a point called the circumcenter. That is an equidistant from the vertices of the triangle. In this example, if P is the circumcenter of triangle A, B, and C, then PB is equal to PA, which is equal to PC. So let's see them on the graph. So PB, which is right here, is equal to PA, which is equal to PC. So since P is in the center of this triangle, all of these segments that are coming off the vertices are also going to be equal. So let's use that information to do example 2. Example 2 says a stove S and a sink K and a refrigerator R are positioned in a kitchen, as shown. Find the location for the center of an island workstation so that it is the same distance from all 3 points. So using the theorem we just proved, a point that is equal from all 3 points is found by using the perpendicular bisectors of the triangle formed by those points. So what we're going to do is we're going to draw a line, and it says use a ruler, which I don't necessarily have with me, but we're trying to make all of these distances equal. And once we do all of these distances equal, whatever is the center is going to be where our island is going to go, and let's call that island C. And all of these are perpendicular. I drew them from the angles. I'm supposed to be drawing them from the sides, like this, because remember they are perpendicular bisectors, so they form 90-degree angles. So what this means is that the distance from each of these segments that were divided are the same. And since I don't have a ruler, I'm not able to find the exact distance, so it's okay if we just look at that diagram. So C, about right there, is where the island would go. Okay, let's look at the next theorems. The angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. In the example, if BF bisects angle DBE, FD is perpendicular to BD. So BF is this line right here, bisects angle BDE, which is this angle here. This means that FD, let me change my color here, FD right here is perpendicular to BD right here. And FE here is perpendicular to BD. So by this logic, DF is equal to FE. DF is equal to FE. So this is equal to this. The next theorem is the converse of the angle bisector theorem. If a point is in the interior of an angle, is equidistant from the sides of the angle, then is on the bisector of the angle. So looking at this example, if FD is perpendicular to BD, okay, and we see that by the perpendicular symbols, and FE is perpendicular to BE, again, we see that, and DF is equal to FE, we see that by these lines here, then BF bisects angle DBE. So this bisects it. So let's look at example 3. In example 3, it wants us to find each of the measures. So in order to find measure XY, we know that XY, which is right here, is equal to XW by that theorem. So XY is equal to XW. Well, since XW is 7, that means XY is 7. Okay, so that one was easy enough. Now it wants us to find angle JKL, which is this angle right here. Well, since LJ is perpendicular to KJ and LM is perpendicular to KM, that means LJ is congruent to LM. And L is an equidistant from the from the sides of angle JKM. So by the theorem, since KL bisects angle JKM, then that means that the measure of angle JKL is congruent to the measure of angle JKM. So that means the answer is 37. So the measure of angle JKL is 37, since the measure of JKM is also 37. Okay, let's look at C. We need to find SP. Well, in this part, SP is equal to SM. So SP is equal to SM. And SP is 6x minus 7, and SM is 3x plus 5. So we need to solve for x, and then we can plug that in to find SP. So minus 3x to both sides. We get 3x minus 7 equals 5. Add 7 to both sides. We get 3x is equal to 12. Divide by 3. X is equal to 4. Now we're going to plug that x equals to 4 into SP. SP is equal to 6x minus 7. So 6 times 4 minus 7, we get 24 minus 7, which is 17. 17. Okay. Now let's look at the next theorem. We have the in-center theorem. The angle bisectors of a triangle intersect at a point called the in-center that is equidistant from the sides of the triangle. In this example, if P is the in-center of triangle ABC, then PD, which is right here, PE, and PF are equal. Okay? So let's use that theorem to solve example 4. So example 4, it says find each measure if J is the in-center of triangle ABC. So first we need to find JF. So by the in-center theorem, since J is equidistant from the sides of triangle ABC, JF is equal to JE. So JF is equal to JE. Find JF by using the Pythagorean theorem. So we know that JF is equal to JE. Okay? On JE, this is a triangle, so let me draw this out here. So JE is this. This is 15 and this is 12. So we're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. Well, we have c because that is the hypotenuse. We have a, and so we're missing b. So I'm going to plug those numbers in. 12 squared plus b squared is equal to 15 squared. Well, 12 squared is 144 plus b squared is equal to 15 squared, which is 225. Well, if we subtract 144 to both sides, we get b squared is equal to 81. And if we take the square root, we get b is equal to 9. Well, b was also JE, and we know that JE is equal to JF. So that means JF is 9. Okay, now let's find the measure of angle JAC. We're going to use that same diagram. Since BJ bisects angle CBE, the measure of angle CBE is equal to 2 times the measure of angle JBE. So the measure of angle CBE is equal to 2 times 34. So let's see that on the diagram here. So JBE is this angle right here, 34. And CBE, let me change my color for this one, is this entire angle, this whole thing. So that means it's double that. So the measure of angle CBE is equal to 2 times the measure of angle JBE. BE, which equals to 2 times 34, which is 68. Okay? On the other side, we have the measure of angle DCF is equal to 2 times the measure of angle DCJ. So we have 2 times 32, which is equal to 64, and that's this angle right here. So we know that the measure of angle CBE plus the measure of angle DCF plus the measure of angle FAE is equal to 180, since we know that all the angles of a triangle add to 180. So we have 68 plus 64 plus the measure of angle FAE is equal to 180. So if we subtract 68 and 64 to the other side, we get the measure of angle FAE is equal to 48. Well, since AJ bisects angle FAE, 2 times the measure of angle JAC is equal to measure of angle FAE. So 2 times the measure of angle FAE is equal to 2 times the measure of angle JAC. So that means in order to find the measure of angle JAC, we have 48 is equal to 2 measure JAC. So we just divide both sides by 2 to find the measure of angle JAC. So the measure of angle JAC is equal to 24. Okay. And that concludes the notes for 5.1.